Galville is a cuaig popper hen ceshani. The approximate length of the day in Galway measured in hours from sunrise to sunset may be calculated using the function f of t is equal to 12.25 plus 4.75 sine 2 pi over 365 multiplied by t, where t is the number of days after March 21st and 2 pi over 365 t is expressed in radians. So we just need to be careful with that. We're either using our calculator in radian form, or we could use, instead of 2 pi over 365, we can use 360 over 365. So other things to note is that when we do find t, it's the number of days after March 21st. So if we're looking for a specific date, we need to be careful with that as well. So the f of t gives us the length of the day, and t is the number of days after March 21st. So the first thing we're asked to do is find the length of the day in Galway on June the 5th. That's 76 days after March 21st. Give your answer in hours and minutes correct to the nearest minute. So really what they're asking us to do is find the f of t when t is equal to 76. So I'm just taking my function, I'm substituting in 76 for t, and then just simplifying. So again, just to note, in the calculator we need to put it into radian form and use 2 pi over 365, or in degree form and just put 2 pi in as 360. When we simplify, we're going to get 16.837. So this is 16 hours and 50 minutes. So we should be very comfortable with changing 0.835 from hours. So 16.835 is just in hours. So changing that into minutes, we would just multiply 0.837 by 60 to get 50 minutes. The next part asks us to do the opposite really. Find a date on which the length of day in Galway is approximately 15 hours. So they're asked us to find t when the f of t is equal to 15. So we're going to let our function be equal to 15 and solve for t. So solving for t, I'm using 360 instead of 2 pi. So 15 minus 12.25 is going to give me 2.75. Then I'm going to divide on the left by 4.75. It's going to give me 11 over 19. So sine inverse of 11 over 19 equals 360t over 65 at 35.38. So when I multiply on the left by 365 and then divide by 360, I'm going to find that t is equal to 35.87. So they asked us to find the date. So therefore, we have March 21st plus 36 days will give us April 26th. Find the f dash of t, the derivative of the f. So we'll just make a note of our function. So when we differentiate 12.25, it's just going to go to 0. We need to use the chain rule then for the sine part of the function. So when we differentiate sine, we get cosine. So we're going to get 4.75 cosine and then everything that we have for the angle. And now we have to differentiate inside the bracket. So when we differentiate that in terms of t, we're going to be left with 2 pi over 365. So to simplify, I'm going to multiply 2 pi over 365 by 4.75. And I'm going to get 19 pi over 730 cosine 2 pi over 365t. So that's our part C. Part D, find the length of the longest day in Galway. So we have the function the f of t, and it's in terms of t. We know that the f of t represents the longest day, and t is the number of days after a certain date. So if we use differentiation, we can find a maximum point. We can find maximum x and the maximum y that relates to that value. We know that we find these points when the derivative is equal to 0. So we can find the maximum t and the maximum f of t. So going over to the function that we have already differentiated, we're going to let this be equal to 0 in order to find our maximum turning point. So maximum turning point, or our max t and f. So if our function is equal to 0, then the cosine of 2 pi over 365 multiplied by t is going to be equal to 0. We can think of dividing both sides by 19 pi over 730. So again, remembering if I'm using 2 pi over 365, it's in radian form. So that when I have cosine inverse of 0, I don't use 90, I use pi over 2. And I'm solving for t. Pi's will cancel. So t is going to be equal to 91.25. So therefore, I know that the day with the maximum amount of hours is 91.25 days after our given date. So they asked us for the maximum amount of hours. So I'm filling in 91.25 into my function. So I have 12.25 is 4.75. So it's my original. And that's going to give me 17 hours. And on to the last part. Use integration to find the average length of the day in Galway over the 6 months from March 21st to September 21st, 184 days. Give your answer in hour and minutes, correct to the nearest minute. So if we're looking for the average value of the function, we're using 1 over b minus a, and we're integrating our intervals b and a, the f of t in terms of t. So they've given us an interval of 104 days. So a is going to be 0 and b is going to be 184. So we need to integrate, and we're going to leave the 1 over 184 to the very end. So we get 12.25t. Again, like with the previous part, we're integrating all of this. It can be easy to make a mistake. So to simplify what we're doing, 4.75 isn't really going to be included in the integration part in terms of sign. So just leaving that to the side for the moment. If I simplify and just think, okay, what would I do if I want to integrate sine 2t? It's going to be minus cosine 2t over 2. So back to my function. We're going to have plus 4.75. So integrating now with sine, I'm going to get minus cosine of my angle. So 2 pi over 365t. And like we had over 2, here we're going to have it over 2 pi over 365. And put in my intervals. And I'm just going to simplify. So I have minus 4.75 multiplied by 365 over 2 pi cosine 2 pi over 365t. So when we're dividing with a fraction, we multiply by the reciprocal. So that's why it's changing from 2 pi over 365 to 365 over 2 pi. Again, on the next line, I'm just going to simplify further. So now that I've simplified, we need to fill in the values for the interval. So we substitute in 184 for t first of all, and then we subtract what we get when we substitute in 0. Again, I'm leaving 1 over 184 till the end. So I've substituted in my 184. Again, just the past couple of steps that I've done, it could take maybe fewer steps. I just want to make sure that it's clear what I'm doing in order to simplify it. And now I'm just going to substitute in the 0. So making sure that I have radians on the calculator for all of this, I'm going to get 2529.843. And for all of this, 0 minus, so just minus 275.935. So when I add these two numbers, because minus and minus will give me a plus, and divide by 184, I'm going to get 15.249, which is equal to 15 hours and 15 minutes.